Alright gang, today I want to take a dive into the noise floor and discover what the limits are, and also find out if there is performance available that big audio manufacturers might be hiding from us. So let's begin. I present to you the humble dynamic microphone, a simple design with no active circuitry. The self-noise or hiss is representative of the impedance of the microphone. With some math, we can make good estimates as to what the noise of a dynamic microphone might be. But in reality, this isn't the whole story. We'll be plugging this mic into some mic amplifier that will add noise along with the noise of the microphone itself. Manufacturers usually state this amplifier noise as EIN, or equivalent input noise. They may list this noise in dBV instead of the proper dBu, which will look about 2 dB better. They may also list the noise as A-weighted instead of unweighted, which will look roughly another 2 dB better on top of that. Using this little online calculator, we can determine that a 150 ohm load at room temperature with 22 kHz of bandwidth should give a theoretical noise floor of minus 130.4 dBu. That's not dBV and not A-weighted. So anyways, while reading around the internet, I came across this Swiss portable audio recorder, the Sonosax SX-R4 Plus. And in the fine print, it mentions 135 dB of dynamic range. But the United States version is limited to 114 dB. I thought America was the best, but clearly we have failed. So with a little more research, I found this application note published by Texas Instruments, stating that the dynamic range will increase by 3 dB for every doubling of the number of analog to digital converters used in parallel. So if I had an 8-channel converter with 114 dB of dynamic range per channel, summing 8 channels together should improve the dynamic range by 9 dB, pushing to 123 dB. Now this is still shy of the Sonosax recorder, so they are probably using a different method, perhaps dual gain, but using multiple channels in parallel is so simple that anyone can implement it. I could possibly get lower noise by making a big 8-split Y cable and plugging a single microphone into 8 channels, but this won't work if the input impedance drops below 1 kiloohm, as it would put too much strain on the microphone. Luckily for me, I have access to this Midas DL251, a 48-channel stage box with each input being 10 kiloohms. So if I combine 8 inputs together that are 10 kiloohms, I'd expect the microphone to see a 1.2 kiloohm load. So I got to soldering a big Y cable, and would you look at that? It works. I was able to increase the dynamic range by 9 dB. But this doesn't mean all noise is lowered by 9 dB, only the converter noise. I'm seeing a reduction of noise closer to 2, maybe 2.5 dB with the analog gain at maximum with the dummy load plugged in. But that's still audible. This is great for low output microphones like the Shure SM7B. Okay, so if using 8 channels of a Midas DL251 stage box was able to achieve lower noise than a single channel, are there standalone single channel preamps that can perform even better than this mess? So I found a Cranbourne Camden EC1. It's got an impressive spec sheet with an EIN rating of minus 129.5. So I did the test. And using a single channel of this Camden EC1 gives just slightly better noise performance than using 8 channels together of this Midas stage box. I have a studio friend that was kind enough to let me borrow his Grace M108, an 8-channel mic pre with equally impressive specifications and a very important key feature called ribbon mode. This ribbon mode brings the input impedance up to 19 kiloohms. So let's use all 8 channels of this Grace M108, which should present as 2.3 kiloohms to a microphone. Now look at that. Even better noise performance than the Camden EC1, even if not by much. Something to consider here is that this is better noise performance than a cloud header or a lift fetter. I bought an SC Electronics DM2 inline mic amp, and you can see that it performs about the same as a single channel of the Midas DL251. I won't be bothering with these inline mic amps. Here is a sample of me talking into a pair of vintage Electrovoice RE11 microphones. One mic into the Midas DL251, and the other mic is split to 8 channels of the Grace M108. Test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'd like to take this idea farther and try 8 channels of these Camden mic amps together. But unfortunately, I'm not printing money right now. If Cranbourne is listening and just happened to send me 8 channels of Camden 500s in a 500 series rack, please, I'd love to do this test and extract every quanta of signal out of this old Electrovoice microphone. But I had an idea. What if, just like using preamps in parallel, we used microphones in parallel? I present to you 3 Shure SM57s held together with black silicone rings. Test. 1, 2, 3, 4, 5, 6. 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 I noticed that putting 3 mics together like this reduces the noise by about 4 dB, but also kind of reduces the brightness in high end, but not in a bad way. I thought for human voice, it actually sounded decent, like I could track a podcast with this. As far as noise and hiss is concerned, there is a better way. Condenser microphones. Fast and compliant diaphragms, higher sensitivity, that translates to lower noise, right? Well, sometimes not. I put 4 microphones to the test here. A Shure KSM44A as the benchmark. It claims a self-noise of only 4 dB. A Warm Audio WA84 with a self-noise of 16 dB. A Bayer Dynamic M88, and an old Electrovoice RE11. I set the mics up as close as I could next to each other in a closet. The condenser mics are connected directly to the Grace M108, and the dynamic mics will be connected to the Camden EC1 at maximum gain. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here are some other samples of me typing on a laptop keyboard about 2 or 3 feet away. I've EQ matched these samples using an app called Harball to match the other mics to the tone of the Shure KSM-44A. This makes it much easier to hear the difference of noise floor between the mics. You can clearly hear how much more noise the Warm Audio WA-84 has, but this noise isn't the regular hiss that increases with frequency. It sounds like a fan is on. If we listen to the Beyerdynamic M88, it actually has lower noise in those mid-frequencies, surprisingly better for a dynamic mic over a condenser. Let's do these same tests again, but with the older Electro Voice RE11. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clearly, the RE11 is having a hard time keeping up, even on the Camden EC1 mic amp. I want to give a shout out to Whole Tones Productions for letting me toy with his Grace M108. You can check him out on his Instagram at Whole Tones Prod. Link in the description. In conclusion, noise and hiss are unavoidable. Some mics are worse than others. High-end expensive mic amps probably won't help lower the noise of condenser mics because of their inherent self-noise, but good mic amps do help passive dynamic microphones, and using multiple A to D converters in parallel will help increase dynamic range. Oh, and the Shure KSM-44A is an amazingly good microphone, and everyone should own that mic. But that's just my opinion, and I am completely biased.